this is the in my classroom module number 2 for the competitive exam. It's maybe either JEE exam, IIT and others competitive exam, and also the IIT advanced. Okay, see the question paper, and half of this paper I have solved this question to this video. Okay, see carefully. Okay, and next page is this, and this page I'll be solving in the next video. Okay, see carefully. And now see the solution to my welcome to my channel. This is the video about competitive exam. This is for JEE, JEE and IIT and others exam, and advanced also. So here is the in my classroom. This is the MCQ problem I was given here 15. So okay. In my question sheet here, I have given here 30 questions is there. Now today I have to solve this 15 question, and this is a very interesting question, all of them, and see carefully. Okay, so this is the more of the way our problem are integrals. Okay, now see for question number 1. See carefully. Okay, this is here root over tan x, and this is here sin x into and cos x and dx. Looking very easy. Okay, now see, as it is a tan inverse x, so we can express as a like that if we divide by cos x by sin x by cos x, and this we get here tan x, and this is here cos square x. Okay, so see, this is root tan x, and this is here sec square x, and this is here tan x. Okay, and dx. Let here y is equal to tan x. So differentiate, then this is here sec square x and dx. So substitute like that, and this is here dy, and this is here root y, and this is here y. And if we simplify, then we get here y to the power minus half and dy, integrating both sides also, and this is a half plus 1 minus half plus 1, this is minus half plus 1 plus c, and c this is 2 by 3. Okay, this is here wrongly written, and this is here 2 into root y means tan x. Okay, so the option here is first option. Okay, for second I need to space here, so that's why I use this question solution. Okay, now for 2, very interesting question and my favorite problem. These all are x square minus 1 dx, x to the power 4, and this is 3x square plus 1, and this is here tan inverse x square plus 1 by x. Okay, and students, see the solution here. If we divide it by this x square by x plus 1 by x, so we get here x plus 1 by x. If we let here y as a y, so we can differentiate dy is equal to 1 minus 1 by x square and dx. Okay, and now we have divide numerator and denominator part by x square on these two parts. Then what we get here, 1 minus 1 by x square and dx, that is we got like that. And see here, if we divide it by x square, then this is here x square plus 1 by x square and plus 3, and also this is here tan inverse x plus 1 by x. Okay, and now see, and this is here dy, and we can express in place of that x plus 1 by x whole square minus twice ab. So we can write here y square minus 2 plus 3. Okay, and this also are tan inverse y, and this is equal to dy by y square plus 1 into tan inverse by c. If we differentiate tan inverse by, then we get there 1 by 1 plus y square. So again let like a z is equal to tan inverse y. So differentiate this, dz is equal to 1 by 1 plus y square and dy. So that's why, and this by this as a dz and by z here. So log to the base z mod z and plus c. Now look here, log to the base z and z here is a tan inverse y. And this is here y means x plus 1 by x here and plus c. So this is tan inverse. Okay, now see which option is here. Log to the base z tan inverse x plus 1 by x plus c. This is c. Okay, so I think all of you better understood. Very interesting question. And now for the third. I need to be a space there, so that's why it is yes. Now see for third, and this is I10 x to 10 and sin x dx. So that's now I am divided by in, and this is 0 to pi by 2, no, without limit. So that's why we noted that jn without limit. Okay, now this is the integral x to the power n and sin x and dx. So this is the integrating by u into v method. This is x to the power n and this is sin x and dx. And if we differentiate this, we get here n into x to the power n minus 1 differences. So n into x to the power n minus 1. Okay, right now if we integral this, then we get here minus cos x, and this is here and dx. This is the u into v method. Okay, x to the power n minus, and this is here cos x. Okay, now see plus n x to the power n minus 1, and this is here cos x and dx. Cos x and dx. Okay, see here, this is a sine, but it is here a cos. So again we apply the u into v method. Okay, so this is n here. Again we repeat the u into v method, integral this and cos of and dx minus, if we differentiate then we get here n minus 1 x to the power n minus 2, and integral of cos x here is sin x, and this is that dx. So this is jn minus x to the power n cos x multiplied by that n into x to the power n minus 1, and this is here sin x, and multiply that n into n minus 1, okay, x to the power n minus 2 sin x and dx. So now we want to use like in, and this is with the limit of 0 to pi by 2. In the question here is 0 to pi by 2, so that's why we can use the limit here x to the power n cos x and 0 to pi by 2. This is n x to the power n minus 1 sin x and 0 to pi by 2. This is n into n minus 1, and this is in minus 2. So see, if we put pi by 2, then cos pi by 2 is 0 here. If we put pi by 2 on x, and this is there 1, so this is 0 actually, and this is n, and into pi by 2 whole to the power n minus 1 and sin pi by 2. Okay, and now this is here minus, this is here minus n into n minus 1 into n minus 2. So we have to find the value of I10. So see, I10 plus 19 into I8. Now put here I10. So this is here n into, this is pi by 2 means 1. So I10. So 10 into pi by 2 to the power 10 minus 1, this is 9, minus this is here 10, and this is here 10 minus 1, this is here 9, and I8. So I10 plus 19 to I8, 10 into pi by 2, and whole to the power 9. See, this is your question. I10 plus 19 to I8, I10 plus 19 into I8, this is the 10 times of pi by 2 into whole to the power 9. This is your solution. Okay, this is your solution. Okay, 90, this is your 90. And this is your 10. Wrongly written, 90. 10 into, oh, sorry, this is 10 here, okay. This is 90 times of 80, and this is a 10 into pi by 2, whole to the 9. So this is the option D. Okay, so I think all of you are understood, and this is a very interesting question for you. And now for question number 4, and see, this is the two options are given, and some problem are backward calculation to be needed here, as this is the improper integral, so you can, and if we differentiate these or this, then we get the integrand. Okay, so that logic is the very easiest technique to solve the MCQ problem also, and see the technique here. But in definite integral is not possible like that calculation. Okay, see, for question number 4, if we differentiate the option, if we differentiate the option B, then what do we get here? And this is 2, and this is equal to V here, x into e to the power tan inverse x, and differentiate of tan inverse x by, and that is 1 plus x square here. And this is here unchanged, e to the power tan inverse x, and derivative of x is 1, and differentiate of c is 0. So see, if we take a LCM 1 plus x square and take a common, that is e to the power tan inverse x, and then what we get here, x, this is by 1 plus x square here. Okay, now x plus 1 plus x square. Okay, see, this is here. This is here 1 plus x square by, and this, and 2 times e to the tan inverse, but we is absent here. So it is your answer. So it is your, if we differentiate this, then we get here the integrand. This is their integrand. Okay, so this is their option A. Okay, like that method you can solve this problem for MCQ calculation. And now also for question number 5 here. 5 here, and this is your, let us assume this is a, no, not related, this is a I, okay, and 0 to 1, and cot inverse 1 minus x plus x square, and dx. Now see here, 0 to 1, tan inverse 1 by, and take a common here x, and that is 1 minus x here, and dx also, and this is a 0 to 1. Now tan inverse 1 minus x and plus x, then we get here 1 also, so we can like that. Okay, and see, this is here, and you know that inverse formula, and that is here tan inverse 1 minus x and dx plus 0 to 1 tan inverse x and dx. So see, like that. Okay, this is the whole formula of tan inverse that. So 0 to 1 and tan inverse 1 minus x and dx, and this is 0 to 1 and tan inverse x and dx. And students, see here, you know the property like 0 to a and f of x and dx, we can write here 0 to a f of a minus x dx actually. Okay, it is always true. And from that, see here, if 0 to 1 tan inverse x dx, it can be written as like 0 to 1, so tan inverse 1 minus x dx also from that properties. So these two are same integral, so that's why you can write here twice times of 0 to 1 and tan inverse x and dx. Now apply the u into v method. Here is tan inverse x dot 1 dx, and this is here, take a first function, that is tan inverse x and dx minus differentiate this we get here 1 plus x square, and dx here is x and dx. Okay, and now see x into tan inverse x, and by half, and differentiate of 1 plus x square is twice x, so that's why 2. I'm balancing by 1 by 2, and log of 1 plus x square to the base z here plus c. So you can easily substitute the improper integral and to that tan into x into tan inverse x minus half, and log of that 1 plus x square, okay, and this is 0 to 1 here. So this is 2, if we put here 1, so 1 and tan inverse 1 is pi by 4, and if we put here 1 half log 2, if we put 0 0, if we put 0 here, then log 1 is also a 0. This is the answer, and this is pi by 2 minus log 2 to the base. You see the solution, see the option here, and pi by 2 minus log 2, and this is your option B here. So I think better problem for all of you. And see, for 6, you know, students, from the inverse property of inverse circular function, we can write here tan inverse x plus cot inverse x is equal to pi by 2 actually. So see, from that for 6 here, 1 to 3 limit, and tan inverse here x by x square plus 1 plus, and this is tan inverse x square plus 1 by x and dx. So see here 0 to 3, sorry 1 to 3, and this is a tan inverse x by x square plus 1. So you can write here cot inverse x by x square plus 1. From these properties we can write here as a this is a 1 to 3 and pi by 2 and dx. So this is a pi by 2, and this is dx means 3 minus 1, and this is 2, and this is pi here. So this is option B. Okay. So for 7, question number 7, 0 to pi, and this is very interesting question, and need to carefully follow the question here. This is okay, and this is 0 to pi, sorry, and 1 plus cos x, and this is cos square actually x by 2. See again question number 7. Okay, I am wrongly written here, this is here twice x, so that's why I am checking my question sheet, and I have written here wrongly. This is x, not x, and this is here twice x. So this is here twice x, okay, this is twice x, and now right here cos x by 2, 2 are cancelled, and dx here, so dx are missing. So so see 0 to pi, actually pi, and this is root over of that, so we can't take like cos x. This is mod of cos x. Need to write here mod of cos x. Most of the students that write here like cos x, and this is the wrong. So that's why mod cos x. And now see in between 0 to 90 and 90 to pi, and there are the some different values of cos x. So that's why I'm doing here like pi by 2 mod of cos x and dx, and also pi by 2 to pi mod of cos x here. And see here 0 to 90, this is the sale of all, and that's why in case of first ordinate, and there are all the theoretical ratios are positive, so it is a positive, so we can take mod cos x means cos x here. And on the second ordinate, and this is the sale of sine and cosec, and there is only sine and cosec are positive, and second cell, and it goes sine here cos x, so it is a negative on that cell, so that's why, and pi by 2 to pi, and this is minus and cos x and dx. So if we integral cos x, so you get here sin x, okay, and this is 0 to pi by 2, and this is a minus integral of cos x, this is sin x, and this is pi by 2 to pi. So this is pi by 2 means 1, and sin 0 is 0, and this is here sin pi by 2 minus, sorry, sin pi minus sin pi by 2. Sin pi is 0 here, so 1 plus 1 is 2. So she, and this is the first option. So I think very interesting question to using the mod. Okay, and this domain is also an important part of the solving the most problem. And now question number 8. In my first module there was given this question, and also again I solved this question again, and some property for that we mention in this question here, pi by 4 and 3 minus 2 sine square t and dt here, and plus a2y cos t and dt equal to 0. So see the property, this is f of x and phi of x, and this is capital F of x and dx. If we differentiate this, and this is equal to, we can apply f of phi of x, okay? Again differentiating, then this is the phi dash x, minus put that f of x, and this is f dash x here, and this is the property. So from that differentiate this and ddx of, okay, and integral pi by 4 to x and root over 3 minus 2 sine square x. Oh, this is t here, sorry, this is t and dt, and plus dx of a2y cos t and dt equal to 0. Now for differentiating this, 3 minus 2 sine square x, okay. Again differentiation of x is here 1. If we put here root over 3 minus 2 sine square pi by 4 and ddx of pi by 4, and this is a constant, that's why this would be a 0 here, and plus if we put here cos n plus of t y and ddx of y, and the lower limit is 0. If we put here cos a and ddx of a is 0, so like that, okay, this is 0, and this is here when in your question see, this is a 0 and pi by 4 by pi, and this is a pi, so 4 cos y dy dx plus 3 minus 2 sine square x equal to 0. Cos pi, question C, y is pi, x is 0. So dy and dx, x is 0 and y is on pi, plus 3 into 2 into sine square 0, and this is equal to 0. This is minus 1 dy dx x 0 and y equal to pi, plus root 3 equal to 0. So dy dx x equal to 0 and y equal to pi at that point is root 3 is answer. Okay, this is option D. Okay, see carefully, very interesting question. Okay, and follow the question number 9. And see, and ddx of f of x, and that is equal to g of x, you know, and d of f of x, we can write here g of x and dx. Write the integral, that is a to b f of x and g of x and dx. See, g of x and dx, we can write and d of f of x, a to b f of x and d of f of x. So integrating like z and dz, z square by 2. So this is square x by 2, and this is the limit here a to b. So f square b by 2, f square a by 2, and this is the first option. Okay. So okay, this is a very interesting question. And 10, question number 10 and 8 are both the same. So see, here is the integral are given and find dy by dx. So most of the student we can don't get a solution of integral, directly you use the property for question number 8. Okay, so it will be easy. That type of problem, some integral are given here at a function, but we can't integrate the function and find dy by dx. We use the property of that which I have used here. Okay, now see 14. So this is y is equal to 0 to x and 1 minus t plus t square by 1 plus t plus t square and dt. See again, this is the differentiation. Okay, so differentiation means like dy dx. So and ddx of that. So same as 8, follow the 8 which I have used the some property. So 1 plus t square dt. Okay, and this is a property. First put x in place of t, and again, okay, and minus, if we put 0 and ddx of 0 is 0 here, so we get here x plus x square and 1 plus x square and dy dx. And what point at what point actually I have actually this is not t equal to 1, this would be a x is equal to 1. Okay, so and this is here x is equal to 1, so this is 1 minus 1 plus 1 by plus 1 plus 1, this is 1 by 3. Okay, this is 1 by 3, option B. Okay, for 11, and given the function as a binomial, and some of the students are use normal formula, but we use this binomial theorem with integration, and then we get the easily solution of that question. So see here for 11, I use here integration, and this is a c0 and c1x, c2 x square, c3 x cube like that, dot dot cn x to the power n. Okay, see if we integrate c0 x, and this is x square by 2 c1, so c1 by 2, x square by 2 c1 by 2. If we put x equal to 1, then we got the series. So integrating both sides. Okay, so from that integral, doing integrate and dx, and this also integrating this, and see if we put after the integral, if we put x equal to 1, then we get the expression of that, and if we put 0, then okay, so 0 to 1, we use this limit as a 0 to 1. So integrate this 1 plus x whole to the power n plus 1 by n plus 1 and limit 0 to 1. This is your c0 into x, c1 x square by 2, c2 x cube by 3, okay, like that, and cn x square n plus 1 by n plus 1. Okay, this is a 0 to 1. Put the limit here, this is 2 to the power n plus 1 by n plus 1. If we put 0, then we get here, okay, and on the right hand side c0, if we put 1, the upper limit is 1 here, and then this is by 2, c2 by 3, cn by n plus 1. Okay, if we put 0, then all the 0. Okay, so this is your answer. So that is equal to, if we take a LCM, this is n plus 1 and to the power n plus 1 minus 1. This is your answer. This is the option, I think B. Yes, B. Okay, and now for 12. Okay, this is 11. I am wrongly given the number wrong. This is 10, 11. Now see the 12. In your question, just we have followed the question number 4, and this is the indefinite integral. If we differentiate the option and we get the integrand, and same as procedure we can follow this. If we differentiate this we get here 1 by x, and this is here 3 x square by 1 plus x cube, but if we take a LCM, then we get here x into 1 plus x cube. This is here absent, so not possible from the option number A. If we differentiate then B, what we get here C. If we differentiate B, then we get log x, differentiate of log x, this is 1 by x here, 1 by x here, and differentiation of tan inverse x, and that is here 1 by 1 plus x square, and derivative of k is 0 here. So if we take x into 1 plus x square, and this is here 1 plus x square plus x, but we don't get a whole square, so not possible. And C, I know the solution, but I want to express to all of you, so that's why I take option B. Actually option C is right here, C, and differentiate of log x is 1 by x, and C, and this is 2 by 1 plus x square, and derivative of k is 0. If we take LCM, then x into 1 plus x square plus 1 plus x square, and this is twice x, so we can get easily whole square, and this is x plus x cube. See the integrand, we get here 12. Okay, which option? I've done number C. Okay, and for 13, and see, this is the differentiation of f of x, and that is equal to e to the power sin x by x here. So okay, so in case of that, in your function, integral function, that is here, actually it is dx here, and that is an x cube. So that's why you put here d of f of x cube by d of x cube, that is e to the power sin x cube by x cube. Okay, see, d of x cube is equal to e to the power sin x cube by x cube, and differentiation of that is 3x square and dx, and it is here e to the power sin x cube, this is here 3 by x and dx. So for that, this is here 1 to 4, 3 into e to the power sin x cube by x and dx, and that is we can write here, and this is the formation of that. Okay, so 1 to 4 d of x cube, this is here d of, and this is here x cube, 1 to 4. 64 minus 1, 63, and given that the f of k minus f of 1, okay, and d of, sorry, and this is d of f of x cube, so d of f of x cube, I'm wrongly written, f of x cube 1 to 4, so this is f of 64 and f of 1, that is f of k which is given, this is f of 1, so f of k minus f of 1, so compare with that, so k is equal to 64, so k equal to 64, option C. Okay, very important question 13. Okay, now look the question number 14. It was a very interesting question. See here, x square by a square plus lambda, y square by b square plus I think this is a mu, not lambda. Okay, 1. Differentiate this twice x by a square plus mu, twice y dy by dx by b square plus mu, and this is 0. So x by a square plus mu minus y into dy by dx by b square plus mu. Let us assume as a k. Same. And from this we can, and this is as a 1, okay, and this is as a 2. Now a square plus mu minus b square plus mu, mu and mu are cancelled. So this is a square minus b square. From that, and this equal to, from 2, this is k by x, x by k. From this is b square by mu, this is y, y1 by k, and this is equal to a square minus b square. And y1 means, and that is since dy dx here. So x minus y, y1, and take LCM k, a square minus b square into k. This is 3. Now from 1 and 2. Now from 1 and 2. So this is your x square by a square plus mu, that is x by k. Okay. This is plus y square by mu, b square plus mu. We can easily from that minus y, y1. This is your k, okay, and this is 1. So x are cancelled. So x minus y and y are cancelled. So y by y1, and this is 1 by k. This is 4. Multiplying 3 and 4. 3 and 4. So see, x minus y, y1, x minus y by y1, that is equal to here a square minus b square into k, and this is here 1 by k. So k are cancelled, so a square minus b square. So now write here x minus y, this is here dy by dx, okay, and x minus, and if we put here dy by dx, then we get here dx dy, and this is here a square minus b square. Very interesting question. And this is the option number, this is the question number 14, and we get here C, and this is the first option, okay. Any second option, okay, look here x, okay, this is the second option, option B. Now check the solution again. This is minus here, okay. Okay, I have wrongly written here, sorry, not B, and this is here wrongly written. This is y1, this is your minus, so this is your minus, so I think this is plus, I think this is plus, okay, this is plus, this is plus from 1 and 2, this is 1 and 2, this is plus, so we got here plus and we get here minus, so this is plus and this is plus. Okay, I'm saying wrong, this is not option B, option A. Okay, very interesting question. Now follow the 15 number question in this video, and this is the half part of this video, and this is of the my module question. And now 15, and this is I have given y equal to cos inverse 8 x power 4 minus 8x square plus 1. Okay, let us assume x as a cos theta sin theta, this is, let us assume sin theta. Then put here cos inverse 1 minus 8x square, this is sin square theta. Then 1 minus x square, this is cos square theta. And this is here cos inverse 1 minus, to our left hand, 4 sin square theta cos square theta, this is here sin square 2 theta. And cos inverse, this is cos 4 theta, this is 4 theta. And 4 sin inverse x. So now differentiate dy dx is equal to 4 by root over 1 minus x square, squaring both sides. Then 1 minus x square dy dx whole square is equal to 16. So this is the 16 option A. Okay, I think all of you better understood. This is a very interesting video for all of you which are want to appear the competitive exam. So bye everybody. Look